Good morning. We're going to continue with the function summary. Notice I've added one more thing. Well, I've added several things, but anyway, we have the function f of x equals 3x squared minus 2x, 3x cubed minus 2x squared. It's a polynomial. F prime equals 9x squared minus 4x. F prime of x equals 0 implies that x equals 0 and x equals 4/9. So now we're going to test for increasing and decreasing, and from that we're actually going to get relative and maximum points. We're not just looking for relative max and min points. We're not just looking for relative max and mins, what would just be y values. We're looking for relative max and min points because we are going to be graphing this at the end. So in order to find where intervals where f is increasing and decreasing, again we start with the number line, and it's always good to label what this is, and this is the f prime sine graph. Hopefully I'll have enough room here. So I'll put on this number line, I will put where f prime is equal to 0, and I just make that little mark there. This will come in more handy when we do things like rationals and root related and other functions, because we'll be noting where maybe f is undefined, where f prime is undefined. So this is 4/9, and this is where f prime equals 0. Now we test. It kind of looks like an X, doesn't it? Now we'll test these intervals in f prime, not an f, and we will get, let's see, if we go way in the negative direction, we have a squared term dominates the derivative. In negative direction we get a positive number, so the derivative is positive, meaning that the function f, the first derivative is positive on an interval, then that means on that interval the function is increasing. So kind of drew that little arrow there for you. And then between 0 and 4/9, we'll use that. We'll use 0.1 again, why not? 9 times 0.1 squared minus 4 times 0.1 is a negative number. So we get a negative in this interval, and maybe it's intuitive, I don't know, but anyway, if the first derivative is negative on an interval, then that means the function is decreasing. So that's another property. So now we go to the right of 4/9, so I just go in the big positive direction. Again, the squared term dominates. Big positive makes a big positive number, and since the first derivative is positive on the interval from 4/9 to positive infinity, the function f is increasing. So I'll draw you a little arrow there. Oops. Oh. Okay, so I dropped my marker head top. So the function is increasing on the intervals from negative infinity to 0, and you can include it. I'm not going to, and I'm not going to use, I'm just going to use a comma. This is just the intervals in which it's increasing. You might want to ask your individual professor how they choose to grade that particular little detail, but I'm not going to include 0 in where it's increasing, even though I could. And then it's increasing from 4/9 to positive infinity. And again, I'm not going to use a union symbol. I could, but I'm just labeling intervals for one thing. I saved a little room right there. And then f is decreasing from 0 to 4/9, and again, I'm not going to include those endpoints. And now we look at relative max and mins. And a relative max or a min point, actually either one, will occur where the function goes from a relative max point will happen where the function goes from increasing to decreasing. So therefore, or where the first derivative goes from positive to negative, as long as the function itself is defined at that point. Well, the function is defined at that point. It's a polynomial. It's defined at every point on its domain. So this, and I just put that little dot there, I know that x value anyway is related to a relative max because it goes from increasing to decreasing. I made that x look like my variable x. And then another point is a relative min, and that's where the function goes from decreasing to increasing, or when the first derivative goes from negative to positive. So that's another little point that will be on the graph, and that will be a relative min. Remember, there's no well, we haven't really determined that, but we already know that the limits as we go to positive, negative, infinity are negative and positive infinity, depending on which way you took it. So we know there's no absolute max or min, but that is actually a last little detail. But our relative maximum point is the first one I have labeled here, will be at, and I'll actually calculate it. I'm not going to be lazy. I'm going to try not to be. It's at 0 f of 0, and that's, again, I call it the relative max point. That's why I'm giving you a point. It's coordinates, x, y. And f of 0 is 0, so we go 0. We test these intervals in f prime. When we get our relative max and min points, we put the x values where the function goes from increasing to decreasing or decreasing to increasing back in the function to get our y values. So that's just a little tip there. So we have 4/9, comma, where we go from decreasing to increasing, we have 4/9 f of 4/9, and I shouldn't make a comma, I should just say that that's equals. And let's see what that equals. 4/9, what do we have? 3 times 4 cubed is 64 over 9 cubed, which is who knows what, which is actually 9 is 3 squared, so 2 times 3 is 3 to the 6th, so that'll be 3 to the 5th on the bottom, minus 2 times 16 over 81, and I'm going to cheat and look at my other work because I want to end this. Where do I have it? Ooh, negative 32 over 243. I really hope that's right, because I don't want to have to redo this video. Let's see. I can't help it. 3 raised to the 5th is 243, and so we have 64 over 243 minus 32 over 81. Oops. Which says I have to multiply 32 times 3, which is 96, and that's over 243, and 96 plus, or yeah, negative 96 plus 64 is 32, negative 32, so yeah, that's right.